and welcome. I am Dr. Pauline Fu. In this video, I will talk about application of simple interests. I will also talk about further topics on compound interest. So first, applications of simple interest. I will compute the maturity value and the present value for promissory notes. Compute present value for treasury bills or T-bills. A promissory note, it is a written promise by one party to pay a certain sum of money with or without interest at a specific date or on demand to another party. For example, this is a promissory note. In this note, the maker is D. Paler. So D. Paler will pay, the payee is Valerie Nursery. D. Paler will pay Valerie Nursery. Okay. A face value of $650. This is the face value. At interest rate 7.25% per annum. And the date issued is October 30, 2018. And the term, the note is 4 months. Okay, so this is an example of a promissory note. Now let's look at another example. A 4-month note for $5,000 is issued on March 31st, 2017. The note bears interest at 10%. Compute the present value of the note on May 1st, 2017, if money is worth 8%. So this is an example of a promissory note. Okay, so let's first draw a time diagram. Okay, there are 3 dates here. The first is March, okay, 31st, 2017. This is one date. And we have May 1st, 2017. And we also have these 4 months. So if today is March 31st, 4 months later, it is July 1st. July 1st, 2017. Okay. And the present value P is 5,000. Okay. So how many days from March 31st to July 1st, 2017? It is 122 days. You can use Excel function days to calculate. Put on 2 days, you get, do the subtraction, you get the 122 days, okay? For example, I just want to show you. I'm going to. So how many days between July 1st, 2017 to March 31st, 2017? So you put July 1st, 2017, okay? And then you put down March 31st, 2017. Okay. And then, oops, this one I have to convert it to the date format. Format cells. It is a date. So it is this date. And now you do the subtraction. You use this one minus this one. 92 days between those two. That's not right. So we want to calculate July 1st, how many days between March 31st to July 1st. So I will try to use another function. I will use days. Okay. End date is this one. Start date is this one. So I still get 92 days. Oh, that is correct if for July 1st, but the question is here, 4 months from March 31st, after 4 months, it is July 31st. Okay, so I make mistake here. July 31st, not July 1st. Okay, then I go back to Excel. So change July 1st to 31st. July 31st. See, I should get 122 days. Okay, 122 days between those two dates. Okay. All right, so let's go back to this diagram here. Okay, and now similarly, you can count how many days from May 1st to July 31st. There are 91 days. 91 days between May 1st and July 31st. Okay, and so those are the dates. I will rearrange my number here. So on March 31st, you have $5,000. Okay. And what is the future value up to here? So this is my P. Okay. And what is the future value on July 31st? That is my S. Okay. So I can calculate this one. Okay. So you can use the formula S equal to P multiply 1 plus RT. P is 5,000. One plus R. R is 10% here. Okay, 10%, so 0.1. And T is the number of days between those March 31st and July 31st. So 122 days. A year has 365 days. Okay. And you end up with $5,167.12. Okay, so this is the value on July 31st, 2017. Okay, now the question asks, compute the present value of the note on May 1st, 2017. So May 1st is here. Okay, so we are going to compute the present value. We call this one maybe P2. Okay, so what is the money here? When you have S, what is the equivalent of money here? Okay, so that is our question. So we use the formula for P, present value equal to S divided by 1 plus RT. S is 5,000, this number here, 5,167 plus 1 plus RT. R is 8%. So 0.08 multiplied by T. How many days? There are 91 days. Okay, 91 days between May 1st and July 31st. So 91 divided by 365. And the final result, you get $5,066.08. Okay, so this is this example. Next example, Treasury bills. A 182-day Treasury bill with a maturity value of 25,000 is sold to yield 3.85%, found the purchase price and interest. Okay. So remember the Treasury bills, this number is the face value. Okay. It is actually the future value. Okay. And the question asks you the purchase price. So what is the present value? The difference between purchase price and face value is the interest. So let's do the purchase price first. Present value equal to S divided by 1 plus RT. And this S is the future value, is the face value. 25,000 divided by 1 plus R, interest rate 3.84%, so it is 0.0384. Multiplied by T. Okay, so 182 days divided by 365. And final result, you get 24,530.31. So this is the purchase price. So the interest is the difference between purchase price and face value. So face value or future value, 25,000 minus purchase price, $24,530. Okay. And you end up the interest is $469.69. Okay, so that is the Treasury bills calculation. Okay. So that is the application of simple interest. We give you some examples. Next, let's talk about some further topics on compound interest. So specifically, we are determining the number of conversion periods. Okay? And we'll compute the periodic and normal rate. Finally, we'll compute the effective and equivalent rate of interest. We are going to achieve those objectives by doing some examples. Okay. The first example, found the number of years it will take $2,000 to amount of 4,550 at 6% compounded semi-annually. Okay, how long it will take $2,000 into $4,000 550. So first, we identify this $2,000 is the PV, present value, and the $4,000 550 future value, FV. Okay. And interest is 6% compounded semi-annually. So I equal to 6% divided by 2. I is 3%. I is the periodic interest rate. Once we identify this, and we have a formula, FV for compound interest, future value FV equal to PV multiply 1 plus I raised to power n. Our objective is to solve for this n. What is n? That is the question. Okay. So both sides, we divide PV. We get FV divide PV equal to 1 plus I raised to power n. Okay. And then we use the property of the logarithm function. So we solve for n equal to ln FV over PV divided by ln 1 plus I. Okay. And then we plug in the numbers. By the way, Ln represent base is E, logarithm with base E. Okay. And then FV equal to 4,550 divided by PV 2,000. And then our ln 1 plus interest is 3%, 0.03. Okay. And then you get the result is 27.8083. And remember this one represent, this 27.8083 represent how many compounding periods. So it is compounded semi-annually. But the question asks you number of years. Okay, this is every half year. So finally, answer for the n, you should use this number divided by 2, because a year has 2 semi-annually. So divided by 2, okay, you get how many years? Okay, so it is 13.90 years. Okay, so this is this example. Okay, next example. Jim borrowed 4,000 today. The repayment of schedule for the loan requires a payment of 1,800 in 9 months and a payment of 2,500 at a time n. The interest rate is 8% compounded quarterly. When should the second payment be made? So that is the question. So first, let's draw a diagram. Okay. So the focal date is t equal to 1. At t equal to 1, you borrowed this amount, and in 9 months, you want to pay 1,800. You want to make another payment, 2,500. On what date? Okay, that is the question. Okay, so after maybe 1 year or 1 year and a half, okay, you make this payment. That is the question. What is this N? Okay. So we need to convert this one. This is future value, 1,800 into this present value here, and then convert this amount also into here. 25,000 is the future value. What is the present value? Okay, and what is the present for $1,800? Okay, so that is our thought. Okay, so I'll write down the solution here. Okay, so this present value 4,000 should be the same as the present value of 1,800. Okay, so the present value is 1,800 times interest rate 8% compounded quarterly. So 8 divided by 4, I equal to 2%. I equal to 2%. Okay, so 1 plus I, okay, 0.02. Raised to power -3. Okay. Why it is a -3? Because t equal to 0 to 9 months, you have 3 quarters. Okay, so that is -3. And then plus 2,500 is the future value. The present value 2,500 multiplied by 1 plus 0.02 raised to power -n. We are going to solve for this n. Okay. So anyway, this is one equation and one unknown n. You can solve for n. Okay. Do a little bit algebra, you are going to get 2,300 $0.82 equal to 25 multiplied by 1.02 raised to power -n. Okay, so again, use logarithm function. -n equal to ln. Okay. 2303.82 divided by 2,500. Okay, this divided by ln 1.02. And you get n equal to 4.1264. 4.1268. Okay. And I have explanation here. The result 4.1268, this is quarters, could be expressed in years by dividing 4. Okay, or in months by multiply by 3. Okay. So this is this question, depending on, do you want to express the n in months or in years? Okay. All right, so this is this one. Next example. Maybe I will jump to the next one here. The objective 3, compute effective and equivalent rates of interest. Okay. If you have 8% compounded annually, okay, and the effective rate for the effective rate, it is just 8%. So how did you get it? Okay. The way you are thinking is you use the principle of $1 and a time period of 1 year to calculate the amount, the effective rate. Okay. So let's maybe do this one. So 8% compounded semi-annually. The question is, what is the equivalent rate? Okay. So semi-annually means 8% divided by 2. Okay. Semi-annually, 1 year have 2 compounding periods, and minus 1, you get 8.16%. Okay, so that is the effective and equivalent rate of compounded semi-annually. So next, 8% compounded quarterly. Compounded quarterly means 8% divided by 4 is the periodic rate divided by 4. And a year has 4 quarters. So minus 1, you get 8.24%. Okay, so this is a period. 8.24% is the effective and equivalent rate of interest. Last one, 8% compounded monthly. Compounded monthly, you have to use 8% divided by 12, and a year has 12 months raised to power 12. The result minus 1, and you get 8.3%, or 8.30%. Okay. So let's look at this example. Find the effective annual rate of interest at which $1,000 will grow to $1,900 in 6 months, compounded semi-annually. So let's identify this 1,000 is the present value. 1,900 is the future value. Okay, so we plug in the future value formula. Okay, so future value FV equal to present value PV multiply 1 plus I raised to power n. Okay, future value 1,900 and present value 1,000. Interest rate, we don't know this I, okay, but we do know in 6 years compounded semi-annually, so number of payments should be 12. Okay, and once you have this equation, one unknown, you can solve for I equal to 0.0549. Okay, but this interest is every half year. The question asks you annual rate, so you have to use this one multiplied by 2. Okay, equal to 2 multiplied by 0.0549. that is the annual rate. It is 10.99%. 10.99%. Okay. All right. That's all for this lecture. There are two major topics. One, applications of simple interest. Two, further topic about the compound interest. Okay. Thanks for watching.